Hello everyone, today we'll be hello guys, welcome to my YouTube channel. Today we'll be doing the first video of solving leetcode problems. So in today's video we'll be solving the first problem, a daily challenge actually, which is about finding the shortest subarray where the bitwise OR of its element is at least a given number k. It sounds complicated, but don't worry, we'll break it down step by step and we'll make it easy to understand. So here's the problem actually. We are giving this array 2, let's take this example. We are giving this array 2, 1, 8 and the target k, which is 10. Our job is to find the shortest subarray where the bitwise OR of all elements is at least 10. So to make this clearer actually, we'll be representing in binary. Let's think of the numbers in binary. So 2 is actually 1, 0, 1 is 0, 1, and 8 is 1, 0, 0, 0. And the target k, which is 10, is 1, 0, I think 1, 0, 1, 0 in binary. So we need to combine bits to activate at least those positions. So let's figure out how to do it step by step. So we will use actually a sliding window to solve this problem. Right now we will be, first step, we will be having an empty window, and we will be setting the value, the OR value, to be 0, and also because the OR value actually is 0 because there are no elements in the window yet and there are no active bits yet. So the active bit is gonna be empty. Okay, now let's start adding the first number. So first we include the number 2, and its binary representation is 1, 0 as we said before, which means it activates 2-bit. So now the OR value is going to be updated to 2, and the active bits are now going to be 2, 1. I'm not going to be writing active bits again, I'm just going to be each line updating their values. Each step we add an element to our window, okay? So here the OR value is now 2, so it's still less than k, which is 10. So we need to expand the window much more. So here in our example, we will be adding to 1, okay? Since we added 1, since its binary representation is 0, 1, which means it activates bit 1. Combining this with the previous OR, which is 2 value, the OR value becomes 3, which is 1, 1 in binary. And our active bits are now 2, 1, and 1, 1, okay? Sorry if I'm just drawing so bad, but yeah. Now, the OR value is still 3, which is less than 10, so we need to keep expanding and adding the numbers. So here, we will be adding the number 8, which is its binary representation, as we said before, is 1, 0, 0, 0. So 1, 2, 1, 8. Now the binary, the OR value will be 11, right? Because it's binary gonna be 1, 0, 1, 1, and our active bits will be 2, 1, 1, 1, and sorry, 8, 1, because all of these bits 2, 1, 8 are active ones. Now this is great because the OR value is now greater or equal than k, which is 10, and we have found a valid subarray. But now we should see if we can make it smaller. So to see if we can make the subarray smaller, let's try removing numbers from the left. So if we try to remove the 2 value here, the OR is gonna be 9, okay, which is its binary representation 1, 0, 0, 1, and the active bits are gonna be 1 and 8, okay? But now the OR value is less than 10, so we can't shrink, we can't just minimize the window much further. So the shortest subarray here is gonna be 2, 1, 8. And yeah, and that's it. The shortest subarray with an OR value of at least 10 is 2, 1, 8, and its length is gonna be 3, okay? So yeah, I hope this visual explanation make it a little bit clear. Maybe it's my first video, I'm not usually explaining with drawing with this and all of that, And let's move to the code explanation where I'm gonna put all of this in the code, okay? Okay, now, this is our main function, where all the magic happens actually. It takes an array nouns and target k, and we will return the length of the shortest sub array, where the bitwise OR of all the numbers is at least k. So if there's no such sub array, we will just be returning -1. So let me just quickly define a helper function, which its job is really simple, which is gonna be telling me which bits are active in a number. So def get bits, for example, and for example, if the number is 1, if 10, its binary representation is 101, it will return 28, which is because those bits are actually on. So we'll be actually now declaring a variable where it's gonna be storing all the bits that are on, and we will start with the smallest bit, which is 1, or 2 power 0, which is 1. Okay, so let's call it value equal to 1. Now, while the number isn't 0, we'll be keep checking its bits. So we'll be doing while element, and if the current bit is active, like a fancy way of saying it's odd, we will add its value to our list. So if the element is, we will be adding its value to our list. So we'll be doing res append and add that value. Okay, now next we will be dividing by 2 to shift to the next bit, and we update the next power of 2. So this is how binary works actually, like 1, 2, 4, 8, and so on. So value, it's gonna be, we'll be updating the next power of 2. Okay, once we have proceeded all of these bits, next then we can just return the result. There is, okay, all right. Now let's set up our sliding window. So we'll be doing left is equal to 0. This is actually the start of our window, just chilling at index 0 for now. The result, which is going to be flag infinite. We're trying actually here to minimize the sub-array length, so we start with infinity, and then we will track how many times each bit is active in our window. Like, think of it as a bit tracker, okay? So state is going to be counter. Okay. Now the state value is going to be 0, because this is the OR value of the current window. So starting at 0 because we haven't added anything yet. So now let's start, as I said before in the drawing explanation, let's start expanding the window with a for loop. So for write element in enumerate nums. Each time we move the right pointer, we are adding a number to the window. So for value in get bits element, if this bit isn't already active, we will be lighting it up for the first time. So if state value, okay, sorry. As I said, if the bit isn't already active, we will add the value of the bit to our OR value. So the state value to value, okay. Next, we will just update the counter for this bit, and it's now part of our party. Let me say, okay, state value plus equal 1. Okay. Now, if our value is big enough, we will try to shrinking it. So the window, we will be trying to shrinking the window from the left. Okay. So while left is smaller than right, element values are going to get bits left. Okay. First, we grab the bits of the number at the start of the window, and then we'll be calculating what happens if we remove this number, like what bits would be just turning off, okay? So let me just say delta is equal to sum of the value for value in element values if state of that value is equal to 1, okay? I hope this is clear for now. Now, if removing this number makes the OR too small, we will be just stopping shrinking, okay? So if the state value minus delta is smaller than k, then we will be just breaking, and then we move the left pointer to shrink the window much more, okay? So left plus equal 1. Now, remove this number's contribution. We'll be removing this number's contribution from our tracker, and then we will be just updating the OR value because we just kick it out some bits, okay? I mean bits, not something else, okay? So for value in element values, we will be just removing this number, as I said, and update the state value, which is the OR value, because we just kick it out some bits, as I said. Okay, value minus equal to 1. Equal to 10, I'm sorry. Okay. Now, if the current window meets the condition, which is OR is greater or equal than k, we check if it's the shortest one so far. Okay? You should make sure of this. Okay, now, if the state value is greater or equal to k, then the res is going to be what? You're going to be the minimum. We'll be keeping the shortest length we have found actually so far, which is going to be the minimum of res and right minus left plus 1. Finally, we will be just returning the result. If it's still infinity, it means we didn't have a valid subarray, so we return -1. So yeah, we'll return a result, as I said, if res is not equal to float, if it's not, if it's still infinity actually. So else we return -1. Okay, I think this is all the code we need for the moment. I hope I didn't make any mistakes. Let's just try running it and see if our solution is efficient. Nice, it's pretty efficient. So thank you guys for everything. This is my first video. I hope explaining will get better every day, and that's it. See you.